So I kind of gave you a little preview of the dimensional analysis method of converting units. But we're going to go over that more. When we're solving problems, you should always check your final units. Make sure that you've got the unit that's being asked for. You should always consider whether the magnitude of the answer makes sense. Now, there are some problems where it's not reasonable to think that you could make a good estimate of whether that makes sense or not. But a lot of times, if you look at it, you can say, well, yeah, that could be possible, or no, that's outrageous. Like if you're calculating the number of people to do anything, and you end up with 0.75 people, is that a reasonable answer? No, you can't have less than one person. So, sometimes looking at that, you can say, oh, yeah, I did something wrong. The most common thing that happens is you've got your conversion factor upside down. You're multiplying instead of dividing, dividing instead of multiplying. And that'll make your magnitude go off in one direction or the other. So you look at your final answer and you're like, no, that's not possible. And then you go back and look at your work. These conversion factors that we're just learning about, because they are equal to 1, you can write them upside down and they're fine. So you can take 12 inches per foot or 1 foot per 12 inches, like I showed you. They're equal to 1. You can tip 1 upside down. 1 over 1 is still 1. So those are some things to keep in mind. A solution map. Okay, I'm a visual person. I like to see things, and if I can't get a picture of them, I like to at least make a mental picture so I can close my eyes and see the atoms doing whatever they're doing. In unit conversion, it's really helpful to have a plan, a map. Have any of you guys watched Dora the Explorer? Yeah, or maybe you had a younger sibling or something that watched Dora. We've had just years and years of Dora the Explorer at my house. Thankfully, Andrew's past that now. But where do you go when you don't know where to go? Who do you ask? The map, right? And the map comes out and the map shows you, oh, to get to the snowy mountains, first we have to go over the, I don't know, what would the roaring river, and we have to go through the scary forest, and then we'll get to the snowy mountains, right? And then they chant it, right? Roaring river, scary forest, snowy mountains, and they say it over and over and over again. That's actually a strategy that works really well for dimensional analysis. Some of these things, it's very obvious. Okay, we're going from this place to that place. Done. Good. Easy. Other times, there's some steps in between. And, some of you may be able to just think of it in your head and then write down the equation and be done with it. And especially when you're just starting out and just learning how to do this, you may need to write it out. You don't have to draw a map with pictures, but you may need to write roaring river, scary forest, snowy mountains, so that you remember where you're going. Because sometimes when you start writing out this equation, you get all engrossed in the numbers and the units and the stuff, and you forget, oh wait, where was I going with this? Then you look up and you've got your little map. Oh, that's right, I need to do this next. So the solution map is a visual outline of what we're doing, and for unit conversions, it's going to focus on the units, because it's all about the units. So, and your book uses this, and I very much teach to this textbook. It's a good textbook, and so I'm pretty much covering almost all the stuff that's in the textbook, and I try to do it in the same way as what is in the textbook. So the solution map for going from inches to centimeters is that we're starting with inches, and we're going to go to centimeters. Okay, this is just a one-step thing. This is an easier problem. How are we going to get from inches to centimeters? Well, we're going to use a conversion factor that relates centimeters and inches. It's going to have the given unit on the bottom and the desired unit on the top. Now, what if we want to convert between centimeters and inches? That's going backwards, right? Going backwards, the conversion factor is going to be upside down. So here we're going centimeters to inches. It's the same relationship, but we're going to put the centimeters on the bottom because we're going to want those units to cancel out. And we'll multiply by inches so that we end up with inches. So this is an example of a solution map. Now, do you have to draw fancy shaded boxes? No. Like for that first one, inches to centimeters. That's probably what your solution map would look like. It's like, okay, I'm starting with inches, I'm going to go to centimeters. So general problem solving strategy. Identify where you're starting. If you don't know where you are, how can you get to where you want to go? Right? If you want to go to Fresno, but you don't know what city you're currently in, you've got a problem. If you think you're in Madera, but you're actually in Tulare, and you get on 99, you're going to go in the wrong direction. You have to know where you are before you can set out on your journey. Then you also have to figure out, where am I going? It's like, well, I know where I am, I'm just going to start going. Are you going to end up at the right place? Probably not. So say, okay, this is where I'm starting, this is where I need to end up, and then figure out, how am I going to get there? Do I need to go over the roaring river and through the scary forest? Or should I be doing this other thing? There's more than one way to get from one point to another, right? So, like going from the Tulare campus to the Visalia campus. You can drive up Mooney, or you can take Bardsley over to 99 and go up to 198 and come back that way. Is one way better than the other? Depends on your point of view. They both get you the same place. Now you could also travel east and go all the way around the earth and come to Visalia. Is that a real great way to get to Visalia from here? No, it's kind of out of the way. But hey, if it gets you there, you've still accomplished the goal. So you may do a problem, and your friend may do a problem, and your path might be a little different. That's okay, as long as you're getting to the same place correctly. So figure out how to get there, and it's a good idea to use a solution map to diagram those steps. In the graphic form, it's just like this. Your given thing, and how you're going to get there to what you're trying to find. So other ideas. Sort. Especially when you've got a word problem, sort the information. Write down the numbers, figure out what those numbers represent. If they have units, write the units down. Then strategize. So that's creating the solution map. Figure out, what am I doing? Where am I starting? Where am I trying to go? How am I get there? And then solving. And that's carrying out this plan that you did. Be sure you cancel units appropriately, and you will be tested on significant figures as a separate thing. But then the rest of the semester, we are going to practice using significant figures and rounding our answers correctly. But it won't be a thing where you did this complicated problem correctly, but because you wrote down the wrong number of significant figures, it's absolutely wrong. So I will correct you on it, but I'm not going to hammer you over the head with it the rest of the semester. Then the last step, which is often neglected, check. That's where you look. Does that make sense? So let's try this. So convert 56 centimeters to inches. So we need to know where we're starting, and we're going to draw a little solution map, and it's going to be very simple. You might be like, oh, I don't need that. Yeah, well, let's just practice. So what unit are we starting with? Centimeters. And then we're trying to find inches, right? Convert centimeters to inches. There's very few words in this one. That's nice. Can we go directly from centimeters to inches? Yeah. So you have to be able to find a conversion factor. If you don't have one in your head, you have to be able to find one in that table in the book or online or something. You have to be able to find it. So we can go directly from centimeters to inches. So now we're going to actually do the solving part. We're going to write down what we were given, 56.0 centimeters, bless you, and times. Now we look at that path. How many arrows are in it? 1. Every arrow represents a conversion factor. So it's this number that you're starting with, 56.0 centimeters, times, and you're going to have a conversion factor. This has 1 arrow, 1 conversion factor, and then equals. Now we're going to put the units into our equation first. So this path says centimeters to inches. These are the units that go in the numerator on the top line. You say, well, that first one isn't a fraction. Well, but we could make it a fraction if we wanted to. That would be 56.0 centimeters over 1, if that makes you feel more comfortable. So centimeters to inches. So your path, centimeters to inches. Centimeters, inches. Those are the units that go on top. Now what we do is we see, well, I need the centimeters to go away. How do I get centimeters to go away? I divide by centimeters. I'm going to divide by centimeters because centimeters over centimeters will cancel out. Centimeters divided by centimeters is 1. Poof, disappears. What unit are we left with? Inches. So we got the units to work out. Now we look at this factor in here, and we have to put some numbers in there. So we need to know the relationship, and we've already discussed that. 1 inch is 2.54 centimeters. So we write in there 1 inch, 2.54 centimeters. Could you put 2.54 inches equals 1 centimeter? No, because that's not true. The unit has to go, the number has to go with the correct unit. When you look that up in the table, it says 1 inch equals 2.54 centimeters. One way to think of this is to imagine that this is the fraction line. And you can tip it to the right and put inches on top, or you can tip it to the left and put the inches on the bottom. But the 2.54 and the centimeters stay together. A very common mistake that students make is they'll get all their units incorrectly. They'll put the numbers in the wrong place. They multiply instead of dividing. So we got our units in place, we got the numbers in place, and now we plug and chug. You just put it in your calculator. 56.0 divided by 2.54 equals. Okay, so I don't have room. I'm going to erase this inches because I don't have room to write down all this mess that my calculator's giving me. 22.0472441 inches. That's what my calculator's telling me. So just in case you've forgotten, you don't have to divide by this 1. You don't have to multiply by that 1. Because when you multiply or divide by 1, it doesn't change the number. But some people say, well, no, I need to just do the whole thing. That's fine. You can do times 1 divided by 2.54. Anything that's on the top, we're multiplying. Anything on the bottom, we're dividing. Okay? It's amazing what we can forget about math. Is this how I should report my answer? No, way too many significant figures. So how many significant figures are in my initial number? 3. Oh, one of those pesky 0. Trailing 0, but there's a decimal point. That 0 counts. Okay, yeah. Oh, a little more practice needed. So that's got 3. This is one of those exact conversions, so we just don't worry about it. So our answer should have 3 significant figures, which would be right here. So the best answer is 22.0 inches. Well, why do we need to write the 0? Well, the 0 is telling us that if we were measuring that out, the uncertainty lies in the tenths of inches. Okay? We know it's 22 inches, give or take just a little part of an inch. So we're going to be very precise in how we write these things down. Any questions about that one? Let's do this next one. Convert 5,678 meters to kilometers. Well, what unit are we starting with? Meters. So our little map here is meters. And what unit do they want us to give? Kilometers. Can we convert from meters to kilometers? Yes, we can. So that's just a single conversion factor. So that's our path. We can go directly from meters to kilometers, and so we'll start by writing down the number that we're given, 5,678 meters. There's one arrow, there's one conversion factor. What unit goes on top of that conversion factor? Kilometers. Because that's what the map tells us. So, we start writing here, we get confused. Who do you ask when you don't know where to go? The map. You go look at the map. Meters, kilometers, okay. Meters, kilometers. So we want kilometers, we need to get rid of meters. So we're going to divide by meters. We're going to put meters down here, and the meters will cancel out and go away. Then we need to know what's the relationship between kilometers and meters. So we said, well, what does kilo mean? Kilo means 1,000 or 10 to the 3. If you want to write 1,000, you go right ahead. I'm going to try to be consistent, and I'm always going to use the powers of 10 for the metric prefixes. So I'm going to use 10 to the 3. So if we can just grasp this, it's really easy. But it may take a little wrestling for you. So here's meter over meter, right? And this is kilo. We're not going to write the 1,000 up here because kilo means 1,000. We're going to write what it means down here. So 10 to the 3rd. Kilo means 10 to the 3rd or 1,000. So when we look at this, meter over meter could cancel out. Kilo over 1,000 could cancel out because a kilometer is 1,000 meters. Do you see that? These conversion factors, the numerator has to equal the denominator. Students don't mess up these numbers as much with the metric conversion factors. They're just constantly putting the number in the wrong place. So I'm using a pattern where the prefix and the number are always going to be on opposite sides. You're never going to have both of them. So you can think of the unit as being the last name, and this is the given first name, and K is the nickname. Question?
Is that saying that there's 1,000 meters and 1 kilometer?
Yes, 1,000 meters is 1 kilometer. That's exactly what it says. So my son Thomas, we don't call him Thomas, but that's his given name. Thomas Kawagoa. We usually call him Tommy Kawagoa. I'm sure at some point he'll want to change that, but not yet. So this is, oops, I pointed at the wrong thing. So this would be like his nickname, Tommy Kawagoa, and this is Thomas Kawagoa. Now sometimes people get called Thomas Tatsuo Kawagoa, the full first, middle, last name. But do you ever say Tommy Thomas Kawagoa or Thomas Tommy Kawagoa? Why would you do that? You don't use the full name and the nickname together. We're not going to use the prefix and what it means together. We're not going to have 1,000 kilometers equal a meter. Okay? When we use these powers of 10 consistently, like what they are in the table, this will always be true. The prefix goes on one side, what it means goes on the other side. Okay? There are other ways to do this, and if you can do them consistently and correctly, you go right ahead. But I'm going to be consistent in teaching this one way of doing it.
Does it matter to you if we put the 10 to the third or the thousand?
No. When you get to those bigger ones, though, like
Yeah. A million.
50 zillion kind of deal, 10 to the 12, you're going to want to use the exponent. Okay, so we've got our units in here. Sometimes people are bothered by the fact that there's no number on top. There's no number on top. It's okay, there doesn't have to be a number on top. If we were going to put a number there, what number would we put? 1. That's 1 kilometer. What we'll find throughout the semester is chemists avoid writing the number 1 unless they absolutely have to. I don't know if we've got a bias against 1. I think it's just that we're trying to be efficient. We don't need the 1, so we often don't write it. How do you do this on your calculator? How do you put 10 to the 3 in your calculator? Well, if we say 1 times 10 to the 3, did we change it at all? No. Does that look like scientific notation? Yes, it does. Okay, so this is how I would encourage you to do this on your calculator. This would be 5, 6, 7, 8. If you want to do times 1, go right ahead. Divided by, and then the way you enter this is 1, that EE or EXP button, 3, and the equal sign. And you should come up with 5.678. So try that. Remember that the EE button means times 10 to the. So 1 times 10 to the third is 1 EE3. There's no times, you don't type in the times 10. Are you able to get your calculator to show you 5.678, doing it that way? If you aren't, I'll be happy to come and talk to your calculator for you. I'm good with calculators. Yours isn't working?